Well, good morning, everyone. Welcome to the annual conference of the Canada-United States Law Institute in its 45th year. On behalf of our co-chairs, Jim Peterson and Jim Blanchard, our Canadian National Director, Kaios Carmody, and our Managing Director, Ted Perrin, we welcome you to this interesting analysis of the Arctic. I'm Steve Petrus, the U.S. National Director of the Canada-U.S. Law Institute. I will be keeping us on schedule today. We have a lot of interesting people to hear from and the issues to discuss with limited time to do it all. So please forgive me if I interrupt things. Also, please keep your video and microphones off during the conference. That does not mean, however, that you should not ask questions. You definitely should ask questions, and to do so, use the Q&A function at the bottom of your Zoom screen. Ted will be monitoring your questions and will provide them to the moderators of the panels. We have an outstanding program today, and there are continuing legal education credits for those seeking them. The CLE activity code will be presented at the end of the conference at 5 p.m. The Canada-United States Law Institute is a joint institute of Case Western Reserve University School of Law and the University of Western Ontario Faculty of Law. It was started in 1976 by Professor Sidney Picker here at Case Law School. The institute has two presidents, being Dean Erika Chamberlain of the University of Western Ontario Faculty of Law and co-dean Michael Scharf of Case Western Reserve University School of Law. Both will now launch this conference. Michael, over to you.
Thank you so much, Steve. Well, good morning. As Steve said, I'm Michael Scharf. Since 2013, I've been the co-dean of Case Western Reserve University School of Law. And as part of that position, I'm also the president, co-president of the Canada-U.S. Law Institute, which we all call CUSLI. As a specialist in international law, I'm extraordinarily happy to welcome you all to today's Canada-U.S. Law Institute conference, Climate Change and the Arctic, Profound Disruption, Uncertain Impact. Our expert panelists and distinguished keynote speakers will cover issues ranging from the transformative changes that are taking place in the Arctic, to emerging national security issues, to opportunities for economic growth and the need for regulation, to the impact on the role of Indigenous peoples. Our presenters from government, academia, and industry will engage the audience in much needed dialogue on these issues. Unfortunately, we couldn't be in person this year, and last year we had to cancel the conference because of the pandemic. But the benefit of the virtual format is that we have over 260 registered participants from all parts of the world joining us live. And on a normal year, we can only fit about 100 into our moot courtroom. As Steve said, CUSLI was launched in 1976 as a joint creation of Western Ontario Law and Case Western Reserve University School of Law. In a minute, I will turn things over to Erika Chamberlain, the dean of our partner school, who serves as co-president of CUSLI. Case Western is very proud to host our 45th annual CUSLI conference. We've had Supreme Court justices, ambassadors, ministers, governors, business leaders, and prestigious academics speak at past CUSLI conferences. And today's lineup is as impressive or more than any before. CUSLI is an important part of Case Western's international law program, which was ranked this spring as a top 10 international law program in the United States by Pre-Law magazine and number 16th best out of 200 by US News and World Report. Through CUSLI, our law school has developed a niche that has brought some amazing Canadian students to study in our corridors and classrooms, including Francois Philippe Champagne, the former Foreign Minister of Canada, and Rosemary McCartney, the former Canadian ambassador to the United Nations. CUSLI's success is due in large part to the engagement of its impressive executive committee, who I'm honored to introduce to you at this time. In addition to Erika and me, the committee includes, as co-chair, the Honorable Jim Peterson. He's a partner at Fasken Martineau. He's formerly Canadian Minister of International Trade, formerly Secretary of State, and formerly a Canadian Member of Parliament. The other co-chair is the Honorable Jim Blanchard. He's a partner at DLA Piper. He was formerly Governor of Michigan and formerly United States Ambassador to Canada. Also on the committee, we have Richard Cunningham, partner at Steptoe & Johnson, known widely as the Dean of the U.S. International Trade Bar. We have Professor Diane Francis, the Ted Rogers School of Management at Ryerson University, who is editor-at-large of the National Post. We have James Graham, Executive Vice President and Chief Legal Officer and Secretary of Cleveland Cliffs. We have Larry Herman of Herman and Associates and Senior Fellow at the Howell Institute. He was formerly a member of Canada's mission to the UN and to the GATT and Counsel for Canada in the International Court of Justice. We have Selma Lussenberg. She is the Canadian co-chair of the NAFTA 2022 Advisory Committee, formerly Vice President and General Counsel and Corporate Secretary of the Greater Toronto Airports Authority. We have Peter Gordon McKay, partner at Baker & McKenzie, formerly Canadian Attorney General and Minister of Justice, and formerly Minister of National Defense and Minister of Parliament. We have Richard Newcomb, a partner and head of DLA Piper's international law practice, formerly director of the Office of Foreign Assets Control at the US Treasury Department. We have Raul Rosado, the Vice President and Chief Legal Counsel of North America and Europe for the Formica Group. And we have Dr. Christopher Sands, the Director of the Canada Institute at the Woodrow Wilson International Center for Scholars and Senior Research. He's also Senior Research Professor at Johns Hopkins University, the Paul Nitz School of Advanced International Studies, known as SICE. Now, we also have the three directors who are super important to the success of CUSLI. Steve already mentioned them, but again, it's Professor Caius Comedy, the Canadian National Director and Associate Professor of the Faculty of Law at the University of Western Ontario. We have Steve Petrus, United States National Director and Director of the Frederick K. Cox International Law Center at Case Western. And finally, the glue that holds the organization together, Ted Perrin, the Managing Director of CUSLI. I know that's a long list, but I wanted you to see how impressive the people are that organize these conferences and make this organization work. And please join me in giving a great hand of gratitude to the members of the Executive Committee. It is now my pleasure to turn things over to my co-president, Dean Erika Chamberlain. Erika.
Thanks very much, Michael. And on behalf of the Canadian partner of CUSLI, it's my pleasure to welcome you here virtually to this annual conference. As has been said, this is a longstanding partnership between our universities, and I'm delighted that it continues to thrive. I'm especially happy this year that the virtual format has made the conference more accessible to a Canadian audience who might not normally make the trip to Cleveland. For those of you who are not familiar with the University of Western Ontario Faculty of Law, or Western Law, as we like to call it, we are located in London, Ontario, which is 1 or 2 hours from the border, depending on which bridge you cross. We have a strong and growing group of international law researchers, including experts on trade and conflict of laws, as well as a strong international law internship program that allows our students to get first-class experiences in offices of the United Nations, the WTO, the World Bank, and a range of international organizations. Western Law hosts the Canada-US Law Institute's annual Distinguished Lecture, which features leading diplomats, academics, or journalists speaking on topics related to Canada-US relations. Just this spring, we hosted Colin Robertson, Vice President of the Canadian Global Affairs Institute, who spoke about working with the Biden administration from a Canadian perspective. We also host several events geared to students, which compare Canadian and American approaches to issues like cannabis legalization, law enforcement, and of course now COVID restrictions. CUSLI hosts 2 premier events every year, an experts meeting in the fall, which is usually hosted in Washington, D.C., and this annual conference hosted by Case Western Reserve University School of Law. We aim to center these events around pressing issues facing our 2 countries, and there are so many of them to choose from right now. We're already looking forward to our next year's events and are considering a number of topics, including US-Canadian approaches to China, market-based and economic development approaches to climate change, and building a sustainable, resilient North America, which could include cross-cutting issues like technology, climate change mitigation, rising geopolitical risk, and social and economic equity. We welcome your feedback on these or other topics you might be interested in so that we can build a terrific program like the one we have for you today. On behalf of the Canada-US Law Institute, I'd also like to recognize the very generous support of our conference sponsors. Our platinum sponsor, DLA Piper LLP, our gold sponsors, Cleveland Cliffs and the Coleman P. Burke Center for Environmental Law at Case Western Reserve School of Law, our bronze sponsors, Formica Corporation, Barrett in America, Charles Schwab, Taft, Stettinius and Hollister, and the Quebec Government Office in Chicago. We'd also like to thank our event sponsor, the event partner, the Canadian Consulate in Detroit, and a number of community partners that help with coordinating on speakers and promotion for this conference, the Woodrow Wilson International Center for Scholars, the Polar Institute at the Wilson Center, the Cleveland Council on World Affairs, the Greater Cleveland International Lawyers Group, and the Northeast Ohio International Business Network. There's a really fantastic lineup of speakers and panelists on offer today, so I think you are in for some really stimulating discussion. I hope you're all staying safe and strong wherever you are today. So I'll turn it back over now to Stephen Petrus to continue with the program.
Thank you very much, Erika and Michael. I do want to point out to everyone that we will have a number of breaks during the course of today's conference. So there will be an opportunity for you to take a break from staring at your computer screen. Our first panel today is titled Climate Change's Profound Disruption of the Arctic. We are very pleased to have as our moderator of this panel, Michael Sfraga, a doctor of philosophy in geography and northern studies, who is the founding director of the Polar Institute at the Woodrow Wilson Institute. A resident of Alaska, his work focuses on the changing geography of the Arctic policy, and the impacts and implications of a changing climate in the Arctic. Dr. Sfraga is an affiliate professor at the International Arctic Research Center, University of Alaska, Fairbanks, and serves as the co-director of the University of the Arctic's Institute for Arctic Policy. You can see and hear Dr. Sfraga on MSNBC, National Public Radio, Bloomberg News, and C-SPAN, and he holds many fascinating and outstanding webinars on Arctic issues through the Wilson Center. Mike, over to you.
Steve, thank you very much for the kind introduction and for the compliment of inviting the Wilson Center and the Polar Institute to this very important discussion. All of my colleagues at the Wilson Center appreciate this as well. And a special thank you to my friend Chris Sands, the director of the Canada Institute, for his support as well. I have the honor of moderating this first panel entitled Climate Change's Profound Disruption of the Arctic, and I'm joined by 2 distinguished experts. My friend and colleague, Professor Hajo Eicken, the director of the International Arctic Research Center and professor of geophysics at the University of Alaska, Fairbanks, and Professor Marcel Babin, Professor and Canada Excellence Research Chair in Remote Sensing of Canada's new Arctic frontier at the Université Laval. Let me begin this panel with some context. As many of you know, the Arctic is not emerging. It's not an emerging issue. It has emerged. It's an interrelated, integrated component of the global environmental, political, social, cultural, economic, and security landscape. We're living in a new globalized Arctic. We have a new ocean opening, at least for part of the year, right before our eyes. With all of the implications of this new reality, many of these issues will be explored by my friends and colleagues later on in different panels, and it's wonderful to see many of them participating today. For context, once again, I'm often asked by members of the Congress, administration, local, national, regional, international policymakers, why is the Arctic important? Is it really changing? How can they better understand the issues at play in the Arctic? Why should they care? Why does the Arctic matter? It's hard for many of them, many policy makers to grasp the scale and the scope of the Arctic and the scale and scope of the challenges of the Arctic. So I came up with a framework that many of my colleagues have heard before. And in my opinion, when I try to explain the Arctic, to me, there are 7 key drivers, seven key themes at play in the Arctic that are literally reshaping the contours of our Arctic. And in my opinion, it's a way to bundle and explain the dynamics of the Arctic. It's a way for people to think about the Arctic. And in the end, it'll be our ability to navigate these key drivers. I have found that each of these drivers, in my opinion, starts with the letter C, and how we navigate each of these C's will determine really how the Arctic emerges later on into our future. So to me, navigating the Arctic's 7 C's is really important. The first C in my framework for legislators and others to think about the Arctic is climate. So how we navigate the 7 C's, to me, is driven by the most significant C, climate change. And this panel is focused on that and the disruption that climate change brings to the region. Let me give you the other 7 C's for context, and then we'll go into the panel. But the first C in navigating the Arctic 7 C's obviously is climate, where the Arctic is warming more than 2 times the global average. Commodities is the second C. Those who think there's a rush for commodities in the Arctic will point to that. Oil and gas, rare earth minerals, strategic minerals. Commerce is the third, the shipping of these commerce, the transportation of these commodities. Connectivity in all of its realms, whether it's broadband, ports, rail, highways. Connectivity is a big driver in the Arctic. Communities don't just want to sustain themselves, they want to thrive, but they have many challenges in this new Arctic. Cooperation is my 6th C. There's a lot of cooperation in the Arctic. Arctic Council, Arctic Coast Guard Forum, research. And finally, the 7th C is competition. There is competition in the Arctic. For now, we're able to manage this competition in all of its realms, but we have to keep our eye on that. That's why the cooperation C is important. But to me, the first C, climate, is the principal driver of almost everything else we see in the Arctic. And that's why today's panel, Climate's Profound Disruption of the Arctic, is so important. And we can only address the challenges of the Arctic or the 7 C's through fact-based, science-driven policy formulation and implementation. So to begin our exploration and discussion on this topic, it's a pleasure to offer the virtual floor to my colleague, Dr. Hajo Eicken. Hajo, the virtual floor is yours.
Thank you, Mike, and good morning, everybody. I'm Hajo Eicken. I'm director of the International Arctic Research Center at the University of Alaska Fairbanks. UAF, for short, is located on the Trothiada campus on the homelands of the Lower Tanana Dene. I'm pleased to be able to give you just a brief perspective on some of the physical and environmental aspects of disruptive Arctic change. In order to give you a better perspective on that, I'll share some slides with you that I've prepared, and then my colleague, Dr. Babin, will take over after this and give you a bit more of a perspective, in particular on the ecosystem changes and their implications in the Arctic. So you should be seeing the slides. Is that correct, Mike? Yes. So the topic of this conference today is disruptive Arctic change. And I just wanted to set the frame slightly differently and emphasize something that I'm sure all of you are aware of, that the Arctic plays an important role both as a disruptor and a provider. And it's really only in recent years that this aspect of disruption has come to the fore. If you look at the photo on the right here, that was taken outside Tuxuk Bay in the Yukon-Kuskokwim Delta in southwestern Alaska. You see a Yupik hunter scanning the horizon for mukluk or bearded seal. The use of the sea ice cover that surrounds and lines the Arctic countries and the Arctic Ocean as a platform and as a provider of services, both to the people of the Arctic, the indigenous peoples of the Arctic, and its marine and coastal ecosystems is an important aspect of the role of the Arctic as a service provider. But there's a range of other services. And these services ultimately are being disrupted and requiring both local and regional and global concerted action in a form of a response. You see some of this disruption here in the photo on the left. This is a much more common type of scene that you see now. This is taken here at Utqiagvik, a community in northern Alaska, formerly known as Barrow. The summers used to be such that you had a lot of sea ice remaining on the oceans over the course of the summer months. And in recent years, the retreat of that sea ice, something that I'll talk a bit more about here in my presentation, has led to larger areas of open water. Fall storms and summer storms then generate these large waves that you see come crashing into the shore here. And there's a great increase in the amount of flooding events and the coastal erosion that comes with it. That is one aspect of the disruption of the services that the Arctic provides. So to put it more broadly, and these are some of the points that both Marcel, Babin, and I will touch on in our presentations, you can think of the Arctic providing key services and benefits to all of humanity, but in particular to the people of the Arctic. And it's the disruption of these services and benefits that is creating some of the challenges that we hope to talk a bit more about today. One aspect, for example, has already been pointed out by the first of the Cs that Dr. Sfraga introduced, and that is that the Arctic serves as an important globally important regulator of the climate system through, in particular, the Greenland ice sheet and glaciers. The Arctic also serves an important function as a regulator of sea level. But then also you see this here illustrated by the photo on the right with a number of walrus hauled out in an ice flow. The Arctic supports marine food webs. It's an important support of biodiversity. It provides food, serves as a transportation corridor, and the cultural services, in particular for Arctic indigenous peoples, but also for tourists that are visiting at intervals, are an important aspect of the services the Arctic provides as well. So I'd like to have you keep those aspects of the Arctic services in mind as we start reviewing some of the changes that we've seen in recent times. And it's also important to understand in the type of context that this meeting and the great roster of distinguished participants that you have here represents, that in the context of legal frameworks, a lot of these services are not regulated such as the services that you would receive if you take your car into a shop and expect that whoever is working on your car is conforming with common business practices, is complying with local and federal laws, et cetera, et cetera. These types of services that you see here, even though they are arguably much more important than the types of services you might get if you're looking for an oil change in your car, are a much more complex set of services that are very difficult and challenging to regulate and parse both on a local and a global scale. And that's part of the challenge of the Arctic, that its global role makes it and I guess that's another C here for your 8 C's there, Mike. It is a challenging, but also an important aspect of the global system. So just a brief perspective on what I like to cover here today. I'm going to talk briefly about the Arctic in a global context. Then I'll focus in particular on the cryosphere, that is all forms of snow and ice and permafrost that define the Arctic and also define its role in a global context, and also give a bit more perspective on why some of these changes we see are so disruptive. And I'll focus on one aspect of the cryosphere in particular, that is the ice cover on the Arctic oceans and its marginal seas, the sea ice, talk a bit about drivers of change and consequences, and then briefly come to some conclusions, again, looking at the Arctic through the lens of a provider and a disruptor. So if we look at the Arctic in a global context, on the right here, you see a graphic that was put together by the Intergovernmental Panel on Climate Change in a special report a couple of years ago that looks at various aspects of the global system, the Earth system, in terms of their responses and potentially disruptive impacts and risks as a result of global warming, largely driven by increases in man-caused or human-caused greenhouse gas emissions. And you'll notice here the Arctic called out, apart from warm water coral regions, the Arctic is a region that at a projected 1.5 centigrade degree global warming, which we know in the Arctic will take the form of an even greater warming through a process that I'll briefly mention here, the amplification or the increase of a global increase in temperature in the Arctic by a factor about 2 to 3. This warming here indicated on the scale here in the left, and apologies to my American colleagues, this is in centigrade and not in Fahrenheit. The warming for the Arctic region, based on both observations and models, is projected to come with severe and widespread impacts and risks, and in particular, a component of strong irreversibility, such that many of the changes that we expect to see are already seeing happening now, in particular those to the cryosphere, such as permafrost, are not reversible in the near term. And those are important points to keep in mind as well as we think about disruption. And of course, a lot of these changes also have global repercussions, as I've already pointed out. So this is one aspect of the global impacts. The other is something that Mike Sfraga already briefly alluded to, and that is the rapid rate of warming of the Arctic. If you look at this figure or the two panels here on the right, what you see is a comparison, the dashed bar here on the left shown for different regions of the Earth, North America over here, and then at the very, or towards the right, you have the Arctic. You'll notice that for the time period 1851 to 1930, the rate of change in temperature for most of the globe is roughly located around 0 degrees centigrade per decade. So you have both upswings and downswings of temperature, natural variations, but then as global warming has started to impact us more significantly for the time period 1971 to 2020, you notice that in recent years here, you see an increase in the rate of temperature change to roughly 0.4, 0.5 degrees centigrade per decade for the Arctic. And that is much larger than for any of the other areas, which are also expected to warm, save with the exception of parts of Europe that are going to experience or have experienced significant warming rates as well. So the other aspect to keep in mind here is that this temperature change and rate of change will continue to remain at very high levels throughout the course of much of the century, much larger than for any of the other regions of the globe. So you can see here that we've already started to enter into this area of much greater temperature increase. And this is something that the Earth has not experienced in recent times, these rapid rates of change. And so the rate of change in itself is a key aspect of disruptive change, and something that may leave us not as well prepared in terms of understanding how the Earth and the Earth system respond to some of what we're seeing happening now. So how does that change express itself regionally? In a study here, Timothy Lenton looked at so-called tipping elements of the Arctic in the context of the Earth system. So changes in external forcing. So this would be changes, for example, in our case of greatest interest right now, changes in the greenhouse gas concentrations in the atmosphere can induce changes in state. That is the state of, for example, the Arctic Ocean in terms of temperature or salinity, the state of the sea ice cover in terms of its thickness and its lateral extent. And some of these changes may then result in irreversible transitions into new states of these different components of the Arctic. And important elements that you see called out here include, for example, the boreal forest that covers much of the northern parts of the North American continent and Siberia. You see also changes in the marine realm here for different parts of the Arctic Ocean. That's something that Marcel Babin will talk about a bit more. I'll briefly cover this as well. And then you see parts of the cryosphere called out here, such as the Arctic sea ice cover, different aspects of permafrost. And a lot of these elements here are in fact directly or indirectly linked to changes in the Arctic snow and ice cover. I'll cover some of the aspects of the work that researchers at the Institute I'm leading, the International Arctic Research Center, are currently studying in terms of disruptive change. This here is another perspective on these elements, tipping elements of the Arctic system and their response and potentially disruptive response in terms of the global warming in terms of temperature and degrees centigrade here. And again, I'd just like to highlight that the Arctic summer sea ice, an important aspect of the Arctic system, is particularly susceptible to disruptive change, something I'll cover in a bit more detail here in a moment. So let's briefly talk about the cryosphere as a defining element of the Arctic. The figure you see here gives you a glimpse of the interrelatedness between a range of different processes and human activities that make the Arctic important as a so-called social environmental system. But you'll notice that a lot of these activities and arrows here in some form or another are associated with different forms of snow and ice, whether it's floating sea ice, permafrost on land, the snow cover play a disproportionately important role in the Arctic. I'd also, though, like to point out that the Arctic Ocean is an important element of the global ocean system in terms of heat and nutrient exchange. And again, this is something that Marcel Babin will talk a bit more about with respect to implications for the biology of the region. Another important point to keep in mind, in particular from a legal perspective, is that 1/4 of the Arctic Ocean, or sorry, the Arctic shelf seas, so the shallow water areas that are lining the land masses surrounding the Arctic, these shallow shelf seas account for 1/4 of the global shelf seas and make the Arctic an interesting region also from the perspective of international law of the sea because of the implications in terms of national jurisdictions. And that's something that some of the speakers later in this meeting here will probably cover in more detail. And then, of course, another thing that we're intimately familiar with both in Canada and the US are mid-latitude weather linkages to the Arctic itself, something that I'm not going to cover in more detail here. So let's talk a bit about the components of the cryosphere here. This map illustrates the regional distribution of key elements of the cryosphere. You see here shown in different shades of brown the distribution of permafrost, in particular continuous discontinuous permafrost here. So you see much of Alaska and Canada being underlain by permafrost. On the marine side, you have shown here for the year 2012, the summer minimum sea ice extent, and wintertime sea ice cover is much more extensive. And then, of course, you have the seasonal snow cover. Seasonal snow and sea ice are much more dynamic in terms of responses to a changing climate. The permafrost and the ice sheets and glaciers, in particular the Greenland ice sheet here, have a more sluggish response, but all of these responses to a warming climate have larger scale implications, both in terms of the albedo, the ability of snow to reflect a vast proportion of the incoming sunlight. High albedo of snow and ice surfaces is a key element of its role as a climate regulator. And in particular, over the ocean's loss of sea ice goes along with a lowering of the albedo and an increase in the amount of solar heat absorbed by the Earth system. But then also over land, the release of methane, a potent greenhouse gas from thawing permafrost, and key aspects of ocean circulation here and sea level are important aspects of the role of the cryosphere. So let's briefly talk about sea ice changes in terms of drivers and consequences in a bit more detail, because that helps illustrate the disruptive nature of some of these changes that we're observing. So shown here is a map of the Arctic Ocean for fall, October of 2019. And what you see here is the so-called sea ice concentration anomaly for October 2019. That is a measure of the amount of sea ice that is present in this region relative to the long-term mean for the past 30 years. So what you might call the longer-term climate. And you'll notice here that for this month of October 2019, large areas, in particular of the Siberian and North American Arctic, have experienced ice amounts or ice concentrations well below those normally found. These areas are actually mostly open water still at this time of year in October 2019. And these larger openings, in fact, are one key aspect of the loss of the perennial ice cover, the year-round ice cover of the central Arctic Ocean that we've seen play out over the past few decades. Reduced ice extent has several implications. It has coastal impacts. If you recall, I showed you that photo of Utqiagvik in northern Alaska here at the tip of the landmass. So these large amounts of open water here expose the coastlines more, implications for coastal erosion, but they also provide, of course, greater access. So it gets back to this question of commerce that Mike Sfraga already pointed out. But in general, what we're finding is that even the perennial ice here in the central Arctic Ocean is more mobile. And this greater ice mobility also, apart from greater access, is associated with significant ice hazards. It's important, again, to keep in mind the rapidity of this change. In Alaska, we've looked at this in more detail through a combination of collaborations with indigenous Yupik and Inupiaq ice experts in coastal communities, remote sensing data, and modeling. And we've seen a reduction in the length of the sea ice season by about 2 to 3 weeks per decade since the 1970s. So you now have several months longer open water extent, and that has major implications. One point I wanted to make in the context of loss of summer sea ice is that we understand very well that this loss of summer sea ice is associated with increase in greenhouse gas concentration, specifically CO2, carbon dioxide. The panel on the right here is from a paper by Dirk Knotz, Julian Struve, and it shows the shown as plots here and as a line based on observations from remote sensing data, gives you perspective on the amount of sea ice area that remains at the end of summer melt in September throughout the Arctic in relation to the cumulative amount, the total amount of CO2 accumulated in the atmosphere over the same time period here. And you can see that as the total amount of CO2 increases, shown at the bottom axis here, there is associated or a direct correlation here in terms of reduction of the sea ice area. This is a phenomenon that's well understood, both in terms of observations, the processes involved. The lines here are Earth system models that also provide projections through the end of the century. You see a significant scatter in some of the models here, but overall, all of them are able to replicate this reduction very well. And the best models are actually able now to give us a quite accurate perspective on this loss of sea ice. The reason this figure may also be of interest in the context of this conference, the co-chairs alluded to this earlier, by holding the meeting virtually and not having people fly, including myself, to be present in Cleveland in person, we're actually indirectly helping preserve part of the Arctic sea ice cover. Nats and Struve have presented an interesting way of thinking about sea ice loss in terms of every metric ton of CO2 emitted, based on this relationship shown here, is responsible for the sustained loss of roughly 3 square meters of sea ice. And if you think about personal production of CO2, I'm looking at my carbon footprint very carefully. We're trying to stay for our home here at a per capita level of about 25 to 30 tons, but that already, as you can see, would be corresponding to a significant reduction in sea ice extent. So that's an important aspect, is the fact that greenhouse gas emissions result in sea ice loss. That sea ice loss in turn, though, has larger scale climate regulation impacts. And it's these connections here, again, that are the underpinnings of some of the disruptive change we're seeing in the Arctic. The same type of thing is true for winter sea ice extent changes. Here's the corresponding image here from March, where you see large scale loss of sea ice in the Bering Sea. Just one aspect that may be relevant in the later parts of the conference here as well is that Bering Strait now is ice choked, so Bering Strait over here, for less than 2 months of the year. And that actually has significant national security and maritime transport implications that some of the other experts later on in the conference might give you more perspectives on. I also want to make sure that I point out here that the observations at the local scale in indigenous or Arctic coastal communities give us a much more detailed and nuanced picture of how these changes play out. For example, the Inupiat in northern Alaska here, these are images and summaries for the same year, 2019, from an observing program that's led out of the International Arctic Research Center with a number of indigenous observers. I just want to highlight here observations from Guy Omnick from Point Hope, who compares his ability to fish from the ice in October of 2011 here with October of 2019, where you see complete absence of sea ice. So these changes at the community level are quite significant, and you'll be hearing more later in the conference from Dr. Daly Sambodoro, the chair of the Inuit Cirque Polar Council, who can provide a much better perspective of what this means in the context of indigenous people's impacts. So then just to conclude here with a brief aspect of one component of disruptive change that I see also as a transition to some of the things that Marcel Babin is going to talk about. I'd just like to highlight some recent findings from a large, now going on to 20-year long-term observing program of Arctic change in the marine sector of the Arctic here across the Siberian shelves, led by Igor Polyakov, one of our research our professors here at the International Arctic Research Center, looking at the role of ocean heat, both in thinning and shrinking of the ice cover, but also in other contexts. So what you see here on the left is a conceptual diagram of the Arctic Ocean that shows basically the surface layer of the Arctic, these blue arrows here that see ice and ocean water moved around in circulation patterns of the Beaufort Gyre and the so-called transpolar drift. The surface ocean, if you look at this cross section of the ocean here in terms of temperature, typically is relatively cold, very close to the freezing point in the upper 50 to 100 meters. It's also much fresher in terms of its salinity then the underlying water layers at depths of greater than 100 to 200 meters, you have the so-called warm Atlantic water that comes in from the North Atlantic and spreads throughout the Arctic Ocean. And one important aspect that is only recently been appreciated in the implications and its magnitude is the fact that this Atlantic water layer, a great reservoir of heat, has been moving towards the surface. Here are data for the past decade from 2013 to 2015, 2018. For this part of the Arctic, this warmer Arctic water is moving up, is putting more heat into the surface ocean, and not just contributing to the warming of the upper ocean, loss of sea ice, but also increase in the nutrient concentrations in the upper ocean, something that Marcel Babin will be talking about a bit more. So then in terms of conclusions, what does this all mean? I'd just like to think about this in a bit more of a temporal context. Shown here are timescales at the bottom, timescales relevant for the natural environment, ranging from the seasonal variations that we see to interannual variations, longer term variations on the scale of 10 to 30 years, and then multi-decadal variations, and superimposed on all of this now rapid change of climate, both in the Arctic and outside. What we're grappling with from my perspective is the challenge these changes now present in terms of impacts on infrastructure. Much of the infrastructure is built and designed with a stable climate in mind, designed for lifetimes on the order of about 30 years or so, some urban community infrastructure, longer lifetimes. And we're finding now that with these changes, the rapidity of the change and its magnitude, and particular changes in the cryosphere in the Arctic, are challenging a lot of these infrastructure underpinnings that are important to a number of processes. And the same thing could be said potentially, and that's something later parts of the meeting can speak to, about how this rapid change is changing both, challenging both legislative or business adaptation responses, as well as the longer term responses to the Arctic. So to conclude, key points: the Arctic cryosphere in particular is an important component of the Arctic as a provider and disruptor. The rate of change of challenges, or that we're seeing challenges, responses, and those who need to respond to Arctic change and require attention. And I'd be happy to take more questions down the line. Thanks.
Thank you very much, Hajo, especially the outstanding presentation, especially somewhere around 4 or 5 o'clock in the morning in Alaska. That's outstanding for noon, but I appreciate that presentation very much. And Hajo did welcome questions, and I would also welcome questions of both of our experts here today. So if you do have questions, please send those in and we'll follow up as time allows. So now, Marcel, I will turn over the virtual floor to you, and then we'll come back for hopefully some questions from the audience. I certainly do have some themes that I'd like to explore as well.
Do you see my slides?
Yes, we can.
Good. Thank you very much. So I will follow up on Hajo's presentation with some reports of the impacts of ongoing changes in the Arctic on ecosystems. I will put some emphasis on marine ecosystems, but not only. And I will also emphasize the fact that the Arctic is really a sentinel of global change with many respect. So just to summarize what we've heard from Hajo, the rate of increase in temperature in Arctic is high, is the highest on Earth. So that's one major change that takes place in the Arctic and has an impact on ecosystems. We've heard also that the extent of the ice pack on the Arctic Ocean is decreasing, as we show here with the black line. And numerical models predict that in summer, during summer, we will reach an ice-free Arctic Ocean
within the coming decades, and probably before
May
the
I
end of the
interrupt you? I'm sorry. May I interrupt you? Are you going through your slides? Because I'm just seeing the cover slide.
Yes, I am.
Okay. So apparently it's not advancing. At least I can't see it advance.
And now you don't see the.
I still just see the cover slide. Maybe we can ask our colleagues from the conference to help us a bit here.
Marcel, maybe you might want to just stop sharing and then try sharing again.
Okay.
Mike, while Marcel is working on that, do you want to take one of the questions here?
I do. You know, the wonderful thing about the Arctic is we all know each other, and both of my cell phones are. I don't know what's happening on the chat, but I have my cell phone, so I've been writing them down. Hajo, one of the questions one of the things you mentioned is irreversible change. One of the questions that came in is this ever reversible? If we were to meet, you know, climate CO2 goals that are discussed this week, if we were to do all the things that we've heard about from policymakers, will we ever return to the Arctic that we have known, or something close to it? Or are we simply just going to have to live with an Arctic that has changed? It's just a matter of degree of change.
So I mentioned this also for the permafrost sluggish response. So part of the change is reversible, but will require, as we now know, several decades to play out. So even if we were to stop emitting greenhouse gases this moment, the way CO2 and other greenhouse gases are redistributed through the system, and the way, in particular, Arctic elements of the cryosphere respond is such that some changes will take time to play out. Sea ice, fortunately, is a very rapid responder. So in that context, it responds quickly, you know, on timescales of a year or two to those changes. So that's the good news. But some other elements of the Arctic, in particular permafrost degradation, are clearly irreversible.
Thank you very much for that. Marcel, we're starting to see your slides again. So there we go. You're now on target. Thank you. And thank you.
You hear me?
Yes, we can hear you.
Okay, good. Just switched on my portable laptop computer. Okay, all right. Yeah, I was just recalling that the Arctic is the most rapidly warming region of the world. And you see the next slide?
Yes.
Okay, good. And that the extent of the ice pack is decreasing very rapidly. It may disappear during summer before the end of the century. And one other major change that is maybe a little bit more subtle is the increase in the amount of fresh water that arrives in the Arctic Ocean, either through precipitation or through the run-ups. So because of an increase of precipitations over the watershed, but also because of the glaciers being melting, we see this fresh water coming in the Arctic Ocean. It makes the ocean at surface fresher, and this fresher water floats like a little bit like oil on water, and it kind of prevents the ocean from being readily mixed, which we will see may be a problem for ecosystems. The other impact of freshening also is that it may make the Arctic Ocean more sensitive to acidification. So what are the impacts on ecosystems? I will start with the ocean, because the ocean is where most of life is present in the Arctic. As you can see on this picture, on land at very high latitude, there is not much life on land, simply because it's very cold. Mostly because it's very cold. It's a little bit like on high mountains. If you imagine they're at very high altitudes, you find that kind of landscape as well. And this is related to temperature. While in the ocean, the temperature is never much below 0 degrees. It's at most minus 1.8 or so. It's never minus 40. And for that reason, the ocean is it's like an oasis. And it's really where you find life in Arctic. And most living organisms in the end depend on the ocean, even those that do not live in the ocean. This drawing is a very simple representation of marine ecosystems in the Arctic Ocean. It's a rather simpler network of organisms with, in general, lower diversity than at lower latitudes. And so you see the main components here with a number of microbes, and then you see fishes, especially the Arctic cod, which is a very important species in Arctic. The small animals and fish feed larger fishes as well as marine mammals. And also because a large fraction of the Arctic Ocean is rather shallow, much of the algae that are produced at surface end up on the bottom, where they feed a rich fauna of sea bottom organisms. And the marine mammals, some marine mammals feed on these organisms. So you see how it works, and it's pretty tightly coupled. One important component on of this network is what you see within the red circles. There's really what we call the microalgae. The microalgae is really, most of the biomass in the ocean takes the form of microalgae and not of large algae. The large algae you see on the littoral represents a small fraction only of the biomass, of the plant biomass in the ocean globally. And plant biomass in the ocean represents, the amount of carbon fixed by plant biomass in the ocean is as important as the amount of carbon fixed by plant biomass on land. So it is small, but it is very significant. And in Arctic, as anywhere in the ocean, those microalgae makes life possible in the ocean. They are at the basis of the food chain. They use sunlight to produce organic matter that can then be consumed by other organisms through the food, the food web. So we'll see that the current changes taking place in the Arctic first affect this level of the food chain, the microalgae. So what we know now, thanks to satellites, because we can see them from space simply by measuring the changes in the color of seawater, we have figured out that the production of the amount of biomass of those microalgae produced within a year has increased since the end of the 90s to now by more than 40%, as you can see on this plot. This increase is due partly to the decrease in the extent of sea ice. The sea ice acts as a blanket on the ocean. When you remove it, there is more light, and these are plants, they like light, so they grow more. That's one reason. The other reason is that it seems that the ocean may be more mixed as well, because when you remove sea ice, you expose the ocean to the wind and to some interactions with the atmosphere, which may promote some mixing, which is good for algae, because mixing brings nutrients at the surface. So that's one impact. It seems that the Arctic Ocean would become more productive in a sense. But there are other reports that say the opposite. In some regions of the Arctic Ocean, and especially in the high Arctic, in the Beaufort, what we call the Beaufort Gyre, off Alaska and Yukon, in the center of the Arctic, there it seems that the increased amount of fresh water coming to the ocean accumulates and make this part of the Arctic Ocean less prone to mixing. Which would transformed the Arctic Ocean into a desert. So this is what these little graphics show. If you look at this curve, what you see here is the decrease in the salinity of seawater at surface from 2004 to 2010. So it's a very short period, but we did observe a significant decrease in the salinity. Water is getting fresher. In parallel, we have observed that at the surface of the ocean, during that same period, there is less nutrients available for those microalgae. And the effect of those changes is the following. First, what we observe is that the amount of the larger microalgae, like the diatoms, which are really the ones that feed the higher trophic levels of the food chain, the amount of those algae is decreasing, while the amount of much smaller algae, much smaller, few microns, which are typical of desert oceans, the amount of those algae is increasing. So you see, we have some contradictory results about the productivity of the ocean and the impact of current changes on the productivity. Now, I only talked about biomass and the amount of biomass, but if we just have for a brief moment a closer look to species, to more specific group of algae or other organisms. It seems that there may be species living in the south that would be invading the Arctic Ocean as it gets warmer. Seawater gets warmer as well. The conditions in general get more favorable to species living in the south. And those species may either replace typical Arctic species, or also we may see coming some species of microalgae, for instance, that are harmful. So one example of documented expansion of a southern species in the Arctic exists for what is this small microalgae that you see here, that is just few micron large. It's very small, but in the North Atlantic, for instance, when they grow and they bloom during spring mostly, they cover the ocean. And the nice thing is that because their cell wall is made of calcite, of chalk, it makes the water whiter, and this can be observed from space. So you see here, for instance, on this picture below, you can see such a bloom of these coccolithophores of Brittany and south from UK. You can see that it's easy to see them. So the nice thing with this species, which is a kind of a sentinel, is that you can follow it from space with satellites. And we could show recently that in the Barents Sea, north of Norway, in the Barents Sea, we could see that the blooms of this species, the extent of the blooms has progressed towards the north. So you can see here the dashed red line, that's the northern limit of blooms of this species in 1998. And the full red line here shows the position of the northern limit of blooms of the species in 2015. So it's a nice example, and it does demonstrate that some species are indeed invading the Arctic. Okay, now if you look, let's look at other levels of this trophic network, at other organisms in this ecosystems that you can see on this drawing. I will give one example for the region of the Bering Strait, which has been very well documented thanks to the Distributed Biological Observatory for many years now. And they did document the response of the ecosystems at several levels of the food chain. So we have a kind of a complete story. It's a region that is very productive. As you know, the Bering Sea is a very productive place where the fisheries are quite successful. It's one of the most productive places in the Arctic Ocean. And we've seen major modification in this region as well. So what you see on the red panel is the changes in sea ice. The red and yellow color show places where there is less sea ice than there used to be. And on the right, the yellow and red areas show places where the production of biomass has increased as a response to the decrease in sea ice. So there also we do see an increase in primary production that it seems to be due to a decrease in sea ice. However, it may look surprising, but if you look at the fauna that lives on the ocean bottoms, and especially at some bivalves that are very important because those bivalves are food for sea ducks, seals, walrus, and some whales. So you see the blue dots, and you see this trend over, yeah, since the middle of the end of the 80s to nearly now. You can see that the amount of some of the bivalves, those bivalves especially that are used as food by these birds and marine mammals, their amount is decreasing. While what you see in red is an increase in the amount of another species, but that is not used as food by diving ducks, for instance. And this is due to the fact that while there's more biomass produced at the surface, all this biomass does not reach the bottom. It's just consumed by other organisms in the water column before it reaches the bottom. And what it indicates is simply that the whole structure of this food web is changing. There's more species from the south. Species of fishes, species of zooplankton. And at about every levels of the food chain, we do see modifications and modifications of the species that are present. Now on land, just briefly on land. So the most spectacular modification of land ecosystem takes place in permafrost, this soil that is always frozen and contains a huge amount of organic carbon, twice the amount that we find in the atmosphere. And this carbon is sequestered. However, because this permafrost, which is just frozen ground over tens and hundreds of meters, is starting to thaw. And at surface, this thawing just elicits degradation by bacteria. Some of them produce CO2 and some of them produce methane. And so you probably know that the amount of these greenhouse gases released by permafrost because it's thawing is increasing. At the same time, what we do observe is a northward expansion of the tree line, as you can see on those two pictures, one taken in 1988 in Nunavik, northern Quebec, and another one in 2008. And as you can see, there's much more vegetation, which modifies also the response of permafrost to climate change. It does has an impact, of course, also on living organisms. And finally, those modifications in permafrost also have an impact on all kinds of infrastructures, including landing strips and roads, for instance, and other impacts that Hajo has shown in this presentation. Now, I've talked mostly about the impact of global warming on the Arctic, but there's many other things taking place in the Arctic, and some of them are not directly related to global warming. For instance, pollution. pollution is one of the major issues, environmental issues in the taking place in the Arctic. And that pollution is mostly produced elsewhere and transported by the atmosphere to the Arctic. So while one may think that the Arctic is a clean place, in fact, it does receive a number of long-range pollutants like persistent organic pollutants and mercury and other ones. And those pollutants, they kind of precipitate, so in different ecosystems, marine land ecosystems, and then they are transported by fresh water, for instance, and they get absorbed by living organisms and bioaccumulated. That's one major problem that we do observe in the Arctic. So that will be it for my short review of some major changes taking place in the Arctic. I will conclude with these few slides. The first one just asks the following question: what's needed to scientifically address Arctic environmental issues? Well, first, I think we still need massive, extensive process studies, scientific studies, multidisciplinary with experts in many different fields, very well organized around major projects. What we need also is more data. More data collected from multiple platforms, which include satellites, icebreakers, land-based research stations, collected by scientists. I'm thinking also about community-based monitoring. We need much more data, and some of those data could be collected using new observing technologies, such as some of that you can see on this slide. Why new observing technologies? Well, first to collect more and better data, but also to compensate for the fact that the Arctic is large. Not many people live in the Arctic. It's hardly accessible, especially in winter, so that we really lack data to understand what's going on there and how the system works in general, so that it's hard to predict what will happen. And for instance, we don't know so much about what's happening during winter. And while winter is a very important season, in fact, the Arctic is not, ecosystems are not sleeping in winter. One of such technologies is one that you see here on this picture. It's a Argo Float. It's a float that is deployed at the moment everywhere in the world ocean. You can see on the map here the position of all the floats that are active at the moment. Nearly 4,000 floats everywhere in the world ocean, but there's not many in the Arctic Ocean. We have started only recently to deploy those floats that can collect and transmit data from the ocean over 1, 2, or even 3 years. They can overwinter under sea ice. We did experiment this deployment of such floats in Babin Bay, for instance, to study the dynamics of microalgae blooms. So just to conclude, most of the documented impacts that I've showed in this presentation are due to global change, are not produced locally, in fact. And that therefore the solutions are to be found mostly globally. We can, of course, mitigate the impact locally, but we cannot prevent those changes to take place unless we address them globally. Thank you.
Thank you, Marcel, very much for that presentation. I thank you both for explaining in a very straightforward and meaningful way very complex issues, linking the oceans to land. And I think it provides for everybody here a context for the rest of today's conference. I've noted a couple of questions. We have about 10 minutes or so, maybe less, for some questions. I've noted a number of questions in no particular order, but I noticed one and then it went away, but it's to Hajo. Hajo specifically, and then we'll get to the research components, but specifically, you captured someone's imagination when you noted that you are tracking your own carbon footprint. And this individual is wondering how you are doing that and what tools and techniques you are using.
Yeah, thanks, Mike. And I actually posted the 2 links to this in the Q&A section. So if you, for those Zoom participants, if you click on Q&A, you'll find the links. One is by the U.S. Environmental Protection Agency. The one I use is by the Nature Conservancy. And I mean, just to, it's sort of an interesting aspect. Alaska Airlines, for example, which Mike and I support, you know, so we definitely do our fair share, even though we're trying to minimize this. Just recently announced a couple of days ago that they're planning to go carbon neutral by 2030. So there's a lot happening in the airline industry in particular. This year is the first year that under IATA, the International Transportation Agreement, airlines have to provide offsets for carbon. So there's increasing recognition that keeping track of these aspects of human activities is important and has impacts on the Arctic. I would like to point out just briefly, since you bring this up, that there's also another aspect to this. I mentioned that the Arctic performs important services on a global scale. There are some companies that have looked at certification of specific products through an Arctic sustainability lens. So one of the examples I had some of my students in one of the courses I taught look at in a bit more detail is in fact a paper company that was using model output to demonstrate that their impacts on the Arctic environment are substantially less than their major competitors. So there's an increasing recognition of these global connections that Marcel was talking about as well.
Thank you. So another question, I'll just read it. You can see it, but let me read it for everyone else. Several world leaders, including President Biden and Prime Minister Trudeau, met yesterday to discuss climate change. A number of states set more ambitious emissions goals, reduction targets. Are the goals established yesterday sufficient to mitigate a climate crisis in the Arctic, or is more Arctic-specific action required? And either of you can take that one first.
Well, as I concluded, I mean, if we cannot prevent what's happening at the moment unless we take actions at the global level, because I mean, what we observe in sea ice, for instance, is due to global warming, not to local warming. And it's the same with invading species coming from the south. It's the same for thawing permafrost. Of course, we can take local actions just to kind of attenuate, mitigate the impacts on people, on infrastructure. We can deal with those changes to make them the least harmful possible. But I think we should really also look at the Arctic as one of the best sentinel of what's taking place at the global level. And we should often put this forward to call for global actions.
Hajo, comments on that before I move on to the next?
No, I think that's a great point, Marcel. I mean, the only other thing I would add is that keeping in mind also that if whatever global temperature increase we're talking about, you have to double to potentially quadruple that for the Arctic, right? So we are now already committed to a warming of the Arctic region that's on the order of 3 to 5 degrees centigrade. That's very important to point out. And that is, of course, a bigger issue in the context of environmental and climate justice that has been increasing topic of discussion. And again, I would point to Dr. Daly Sambodoro, who has a background in law, who I think will have a very, will have an important perspective on this topic.
Thank you. A question, I know we only have a few minutes left. Thinking through from both of your perspectives, right? This is what the work you have provided for, the work you do and have communicated today is fundamentally important, right? Fundamentally important to all of us globally, not just in the Arctic. My question to you is, thinking about the audience that we're standing before, virtually standing and sitting before, The question is, how do you each communicate to lawmakers, policymakers, those who influence both the policies for the Arctic, but also the research agenda for different countries, whether it's nationally or internationally? How do you communicate these complex systems and change to lawmakers and policymakers in a way that they get it and then can apply what you have shared with them in some meaningful manner?
If I may, I mean, these are complex issues, right? And so I was one of our faculty just defended her Ph.D. in climate science communication from George Mason University on Monday, Dr. Kristen Tim. She's looked in great detail at how the U.S. National Climate Assessment has been framed as a topic in the media. Very interesting findings. I think what climate or what science communication, cognitive psychology, and other branches of social sciences are teaching us is that the classic communication models just do not work in these circumstances. Now, of course, in the U.S. congressional staffers, in Canada, parliamentarian staffers are very, very sophisticated people that work closely with the research community and others to make sure that they have the best available science. But in many respects, I think we have to rethink some of the models of how the research community engages in the policymaking process, drawing on principles of what's commonly referred to as knowledge co-production, where you jointly define the problem, or at least are involved and be sure that the legislative process, if you will, and the broader public helps to define the problems that the research community addresses. I'd just like to point out that the recognition that this is an important issue is, for example, the fact that outside of the Arctic Council, outside of other agreements, you have a meeting of the science ministers of around 30 or so countries, the so-called Third Arctic Science Ministerial, that's being hosted jointly by Iceland as a former chair of the, or still current chair of the Arctic Council, and Japan, to be held in Tokyo in a couple of weeks' time. And that process, for example, the fact that you have these science ministers meet because they want to do something about climate change in the Arctic specifically and respond to Arctic change is a great sign that there's recognition at the highest levels of the executive of these communities. But I think at the same time, I'm a member of the Science Advisory Board for that current Arctic Science Ministerial. My sense is that those higher levels of government are also still grappling with what are the best processes that you can put in place to respond quickly enough. That's the big challenge, that the gears of the Arctic Council and some of these other bodies are grinding very, very slowly. No offense to those who are active in those venues. That's an important work, but you just have to consider that as well.
Marcel, we have about a minute left. Do you want to weigh in on that question?
Well, it's always very challenging for us to connect with lawmakers and policymakers. I must say, as you can see, the kind of stuff we are presenting, microalgae are not the most charismatic organisms, compared with polar bears, and we do all kinds of activities to outreach activities, to make this make it interesting. But I mean, it's science, but fortunately, there are processes like the IPCC reports, which I think do a pretty good job. I mean, there was this special report on oceans and the cryosphere, which do distill, all the information coming from the scientific community into the quite simple documents, a more detailed one, and one that is dedicated to policymakers and lawmakers. I think that those reports should be read. They have been, I think they contain the essential information, and it's really written for them. So I guess that's one successful approach, and it's a very solid approach, I think.
Thank you very much. And thanks to you, Marcel and Hajo, for spending the morning here kicking off, I think, the conference in a most productive way, laying a foundation, I am sure, for the rest of these discussions. Thank you both for that. And thank you all for listening. I think if we were all in an auditorium, there'd be a big round of applause. But Steve, I want to turn this back over to you, and once again, thank my colleagues here for sharing their expertise and their insights. Steve, back to you.
Yeah, thank you, Mike, Hajo, and Marcel for providing us a deep look at the physical disruptions of climate change in the Arctic. Outstanding presentation, and you certainly set the stage with distinction for the rest of our conference. It's now time for a short break, about approximately 4 minutes, I see. We will start again at 10 a.m. 10 a.m. sharp, so please be back in 4 minutes. Thanks.